Hello, students. Today we have a very good question on the binary operation, which I'm going to be solving today. Now, the question says an operation asterisk is defined on the set of real numbers by x asterisk y is equals to x plus y minus 2xy. And we are asked to look for the identity element and inverse element and so on and so forth. So I'm going to start with the first thing there. Now, the first thing, remember, this is solution now. Recall what we are given is x asterisk y is equals to x plus y minus 2xy. Now, this is so important. We are going to be making use of it on everything that we are going to do today. So, the first thing, which is to find the identity element. Now, the identity element is represented by the letter E. All right, that shows identity element. And identity element is also referred to as the neutral element. So take note of that, okay? Now, what is the condition that will help us to find the identity element? The condition is x asterisk E must be equals to x. All right, since we've known this, then we'll now move. Remember, I told you we are going to be using this for everything that we need to do. So x asterisk E will be equals to x plus E minus 2xe. Now, if you observe, the y is replaced by E. So it's by virtue of position, all right? So we now replace our E, our y with E. Now we have x plus E minus 2xe must be equals to x using the condition now. Okay, so we have E xe is equals to x minus x. All right, I picked this x to go over this side, over the other side. All right, so we have E minus 2xe is equals to 0. Now this to solve this, we factorize E so that we have 1 minus 2x, all right, is equals to 0. Now mathematically, E will be 0 all over 1 minus 2x, and E is equals to 0. So our identity element, that's the first thing that we are asked to look for, is equals to 0. All right, good. So let's move to the second thing. The second thing is we should find the inverse element. Now, to find the inverse element, we must know our identity element, and we've known our identity element as 0. So therefore, what is the condition to finding inverse element? The condition is x asterisk x inverse must be equals to the identity element. All right, that is the condition. So we move ahead now to actually apply this particular expression. All right, so we have x asterisk x inverse will be equals to x plus x inverse minus 2x, then x inverse. Okay, let me pause here and show you something. Don't make mistake of maybe replacing x inverse with 1 over x. All right, please don't do that. It will not give you what you actually want. Don't do that. All right, so take note of that. Then we continue. All right, now this is equals to the identity element, which is equals to 0. So we have x plus x inverse minus 2x x inverse is equals to 0. Remember, we are looking for x inverse, so we'll pick this, okay, to the other side, so that we are going to have x inverse minus 2x inverse is equals to minus x. All right, then factorizing x inverse, I'm going to have 1 minus 2x. All right, okay. Recall here I'm supposed to have 2x x inverse, 2x x inverse. All right, good, is equals to minus x. Now x inverse will be equals to minus x all over 1 minus 2x. Now applying the law of algebra, simplification of algebra, x in this case will be all over 2x minus 1. Now please, your answer like this and these are all the same, so it doesn't really matter, but the second expression is better anyway. So that is my x inverse. So we found the inverse element. Then let's move ahead to see what is the third question. Okay, the third question says we should find the value of x for which the inverse does not exist. Now, basically, when you have an algebraic fraction like that, now for that algebraic fraction, which let me write it, Roman figure 3, x inverse is equals to x all over 2x minus 1. Now, this is the fraction I'm talking about. You see this fraction, this algebraic fraction. Now, for it not to exist, it means that the denominator must be equals to 0. Remember, anything divided by 0 automatically becomes undefined, that is, does not exist. So what you need to do is to say for it not to exist, then it must be that 2x minus 1 will be equals to 0. So therefore, we have 2x is equals to 1, so that we have x is equals to 1 over 2. Now, this is the only value of x that will render the inverse not to exist. And that is exactly what they asked us to find in the second question. Now, the third question says we should find the inverse of 5 under the operation asterisk. Now, this question is actually very cheap too. Okay, so we are looking for inverse of 5, and inverse of 5 is written as 5 inverse. All right, now for us to do this, it is stated, or that means our x must be equals to what? 5. That is the meaning. All right, so we just apply the formula for inverse, that is the inverse is equals to x all over 2x minus 1, 2x minus 1. So it means 5 inverse will be equals to 5 all over 2 into 5 minus 1. And the answer will be 5 over 9. Now listen, in case you are given a direct question like this to find the inverse, you can actually, inverse of 5, you can actually go back and start working from the beginning to find your inverse. It's actually very simple. I think there's no much explanation to that. All right, so that is that for this question. We've solved all the all the questions. So please keep watching and do not forget to subscribe for more interesting videos.